Good afternoon, sir. This is Juni Insancados again. So today, I will gonna present to you my own design of a Shunt DC generator. So at first, this is the diagram. So as you can see, this is the armature. So this is where the AMF generated. So um, this is the brushes. So as well as this part is the load voltage or the terminal voltage. Then as you also here we can calculate the power generated as well as the power delivered here. So in this part, we will gonna calculate the um, individual current, the IA, the also in the shunt um, current, also here in the load current. So let's start. First, this is the given parameters. So in the armature there are 8 poles, 400 conductors, and has a speed of 2500 rpm. Then the flux per pole is 15 milliweber, and then since it is the armature current path is in wave, so the formula is 2m. Then it is a simplex form, so the multiplier is 1, so that's why I put 1. And then the armature resistance here is equivalent to 0.10 ohms. Then the shunt resistance is 50 ohms. Then the load resistance is 20 ohms. Then also the the brush drop here, so we have a 5 volts. So the first thing we must do is to find the generated EMF here in the armature. So we already know how to find or to calculate using the Epson formula, which is E is equal to number of poles times the speed times the conductors times the flux per pole over 60A. So since we have the values, we simply substitute or put it here. So after putting or then calculate, so after calculating the values, so we have a generated EMF in the armature here, which is equivalent to 1000 volts. So after we got the EMF, so the next part we must do is to find the IA. So IA, but the thing here is in order to get the value of our IA or the armature current, we must use the KVL. So upon applying the KVL, so this is the equation, but here is we don't know yet the VL or the load voltage or the terminal voltage. So but since we have here the resistances of the as we can see, we have here armature resistance, the shunt resistance, and then the the load resistance. So and we can see in this part, it is in parallel. So VL is equal to the voltage here in the shunt field, because it is in parallel. So we can say that at is let's say we can calculate the R total here, the resistance, total resistance here. So let's formulate again the equation. So from here, E minus VV minus IA times RA minus VL, we can um, manipulate it into this equation again. So E, or the generated EMF minus the brush drop minus the IA, or the armature current, times the R total of this diagram, or this circuit diagram. So um, but here as you can see, we can calculate the total resistance by series parallel method. So that's why here I put RA here plus the parallel in this series, then the parallel. So that's why I make this equation looks like here, looks like this. So after manipulating the equation, we can find now the value of IA. So IA is equal to generated EMF minus brush drop over the R total, so RA plus shunt resistance times RL over shunt resistance plus load resistance. So since we have now the values of the said variables, so we must simply put it or substitute. So after substituted all the values, so we can have now our IA, or the armature current, which is equivalent to 69.16 amperes. So going back to the original KVL equation here, from since we have now the value of IA, so we can go back here in this equation. Then we can now have our VL. So VL is equal to E minus VV minus IA times RA. Since we have now all these values, so we simply put or substitute all the values here. So upon computing all the numbers, so we got a load voltage which is 988 volts. So now we can also get the shunt current, or in this part we can get the ISH. So and finding the ISH is we simply use a KVL VIR. So since we have now the VL, since the voltage here is equal to the voltage here, that's why we use VL in the formula. So VL is equal VL over RSH. So 98 over 988 over 50. So now the value of our shunt current is 19.76 amperes. So we can also get the load current here, since we have now the values of VL. Yes, we have now the VL. Then we have also our RL. So we can now have our IL, or the load current. So simply substitute. So 988 over 20. So our value of our load current is 49.40 amperes. So since in this part we use KCL, so we can say that current entering is equal to current go out. So here, so IA is equal to IA shunt current plus load current. So we can check if it is equal. So 19.76 plus 49.40, so we can say that it is equal. So after checking, we can now have our power generated in the armature. So by finding the power generated, so we use the formula E times IA, or the generated EMF times the armature current. So we have a 1000 EMF times the armature current, which is 69.16. So the power generated now is 69,160 watts. Then we can also get the power delivered in our generator. So our RL is equivalent to 49.40 times the VL, which is 988. So the result is 48,807 watts. So since we have now the power delivered, we can also get the efficiency of our generator. So in calculating the efficiency of our generator, so we can have a formula of PL over PL plus power losses, or power losses. So how to find the power losses? So simply, as we can see here in this part, we can say there is a power loss here, as well as here, as well as the in the part of where the brushes are attached here. So now we calculate all the total power losses of our generator. So I squared times RA, so we simply put all the values given a while ago. So this, so the total power losses in our generator is 20,346 watts. So going back to our original formula and finding the efficiency of our generator, so we simply substitute. So our PL is 48,807 over 48,807 plus 20,346 times 100%. So to make it a percent, to have our percentage in our efficiency. So upon calculating this value, so we get a 70% of efficiency. So that would be all for my shunt DC generator. So thank you, sir.